Hi, everybody. Okay, today you can see our title up on the top. We're going to get into some good old fraction operations. And specifically today, we're going to focus in on adding and subtracting. So we've spent the last few lessons working our way through a full review of all of our number forms. We've been working with switching within number forms, and even within a number form, like fractions. We've been working on changing the forms of those fractions. Today, what we want to start doing is getting into doing some operations with them. So you see on your screen right off the bat, there's our first question, and that is going to be our instruction throughout the day. We are going to simplify. And I've put up your first problem. There's your 2/7 plus 4/9. What I want you to do is to tackle that problem start to finish. Now, we should be working on that without a calculator. When you have the instruction simplify, that means that you need to give me your final answer that is exact and has the smallest numbers and fewest operations left over. So we'll talk a little more about that instruction as we go. I want you to go ahead and add together those two fractions. Okay, we're going to pause the video. You're going to get a solution. We're going to come back and check. Okay, pause it now. Okay, we're back. So what I want us to do is just to kind of take a quick peek, and we'll do a quick little confirmation as to whether we have a correct solution or not. We should have gotten down to 46/63 as a final expression. That is, my top and my bottom are the smallest I can make them. And the only operation I have left is that divide by, because if I went and tried to do that divide by, I'm going to get an ugly decimal. Okay, hopefully you got down to 46/63 and we match up. If you did, then what I want you to do is I want you to pay very close attention at the strategy I used to get down to that solution. That you may end up looking at my solution and going, oh, okay, I can skip some stuff that I write. I can change the work to get to that point. If we struggle to get down to 46/63, then I'm going to tell you we've got quite a bit of rust buildup in terms of practice, and you're going to want to be able to tell, okay, was my mistake mechanical? Like it was a silly little calculation mistake? We call those human error mistakes. You know, for some reason you wrote down 3 times 2 is 5. You know it's not 5. But you wrote it down, you made a silly mistake, and it had a consequence. That does not bother us that much from a concern standpoint. It's frustrating, it's annoying, but it doesn't cause me concern. If there are some theory mistakes in here, then those might be some areas where we might have some concern. Like for instance, if your reaction to those fractions were, well, okay, I'll add the tops and I'll add the bottoms, then I would have some concern if I were you. That we clearly cannot add together the tops and add together the bottoms because the top and bottoms are different signs. That is, you take a look, your top was 2 of something, your bottom was 7 of something. That means I had a different size than what I had for my 4 and my 9. So if you made that mistake, I would have a little concern. Now we work to clean it up and we're good. Okay, so the first thing that we need to address. I have 7ths and I have 9ths. And I can't go through and calculate either of those divide bys. 2 doesn't divide by 7 easily. 4 doesn't divide by 9 easily. So that means that I have to get my bits to be the same size. My first one is 7ths, my next one's in 9ths. 7ths are definitely larger pieces than what 9ths are. If we went right back and we took our pie and we broke it up into pieces to be able to get our size, we get the idea. That the first thing I need to do is I need to compare pieces of the same size. You guys know that as I have to get a common denominator. And so in this instance then, I would hope that we would have a common denominator of 60/3. That we should have something in our background that says, well, I know I can always find a common denominator by multiplying my two denominators together. What I just found, though, was my lowest common multiple. I want to talk to you in terms of what you were expected to do in the past. Now, I know that some of you were almost expected to write out your times table, and you would continue to write out that times table, for instance, for 7. And you keep going. You do the same thing for 9. And you keep going. You're looking for 2 of the same numbers in the same one. We don't have anything. So you continue and you extend. I keep going. I still don't have. And finally you go through and you say, hey, look, I got 63rds. Please don't ever show me the blue. And I would love it if we can work past even writing it down. But 63rds become the lowest common multiple, or is the lowest common multiple. And now we can go ahead and we can change each fraction into 63rds. Notice what I wrote down on the page. I wrote one big fraction line already into 63rds. This is one way that you can make your solution a little more efficient. A lot of us in the past would have then went and changed each individual fraction into 63rds. And I'm just going to argue to you, you're writing down double. So skip some of that. So my next action was, if I'm going to change it into 63rds, they all become 63rds. Now, one little point about some of the stuff we write that is purely out of habit. Now my job is to go through and change each fraction into 63rds. That means if I focus in on the first fraction, my 2/7, I have to write down what would 2/7 be equal to in 63rds. And a lot of us go through that algorithm that we addressed last time. Well, what did I do to the bottom? I would have multiplied it by 9. And so I multiply the top by 9. And a lot of us in our fraction solutions would actually write down the red. I really want you to skip that. So much so that if I see you write that red down in your evaluation, you are getting your big boo on your page. Boo. If you know enough to write down times by 9, then can't you just multiply by 9? I don't think that we need to write it down. I think that for a lot of us, we write it down out of comfort or out of habit. So I'm going to ask you, don't be stubborn. Try to be a little bit better. So if we recognize that I would multiply the bottom by 9, then I multiply the top by 9 and I have 18. What you see in orange right now is our first fraction converted. Well, now I can just do the same thing. What would I multiply the 9 by on the bottom to get my 63? I would multiply that by 7. So I'm not going to write it. I'm just going to multiply the top by 7. And now all I have to do is collect my pieces. They're all in the same pieces. I have 18 of something plus 28 of something. So that is 46 of something. Those somethings are 63rds. And so that would be a solution I would love to see from you guys in your adding fractions. So as I started at the very beginning, job 1, be correct. So let's make sure we can get down to the correct value, but maybe we were learning a little bit in there. We were going through and say, oh, okay, so maybe that's a different way that I could write my solution that allows me to be more efficient. If we made an error in there, your job was to try to decipher, was it something that matters or was it something that's annoying? Like if you went through and for some reason you went 4 times 7 and you thought that, I don't know, was 25. So you got an answer that said, that's 43 63rds. Okay, the blue is wrong. But I'm not concerned about it. That's a mechanical mistake that is annoying and we have to get better at. However, if we for some reason said, hey, I need a common denominator 63rds, and then you said, well, I have 2 of those plus 4 of those, and you gave me the green of 6 63rds, now I would be concerned. because we're missing some major theory about keeping our fraction values equal. Okay, if we got down to that, and I'm just going to put down that correct solution so you can see it one more time, then I think if we have that orange solution, we're doing great. Okay, let's jump into the next set of problems for us. So what I want you to take a look at for question B, C, and D right now, it's probably going to feel like we actually are stepping back a little bit. And I might argue that we are. I want to talk to you guys a little bit about theory on these next three questions. So you're coming along with me. I'm making the assumption that you are good on these three problems. I really just want to kind of talk to you about strategy. So if we can all get down question B, and then we're going to focus on B alone. Don't start doing B. I'm assuming you know how. I want to talk strategy. So the first thing, and the reason why I want to talk about B, is we first notice I have different size bits, and if I'm going to add together two things, I need them to be the same size bit, so I need a common denominator. I think if you did that and say, hey, I know I can get a common denominator, multiply them together, there's 80, I think you really have the blinders on. And although you are correct, you have guaranteed that you're going to have a little bit extra work to do in the end. So you might have taken it a little easy at the beginning, but you've guaranteed work at the end. And I'm going to argue to you that's actually not a very good solution. We could be better. So rather than always bailing out and simply multiplying your denominators together to get a common denominator, let's get the lowest one. So you take a look at 4 and 20, and if I was to factor my 20, there's that factor tree again, I can see that I have a 4 in 20. My common denominator, the best one, would actually be 20. Now you can go through your times tables and you can see that 20 is the first number that is in both times tables. So the whole reason I wanted to talk about B was, let's do a little extra work to get the lowest common denominator, not just a common denominator. We can finish this one off together. To get the 4 to turn to a 20, you had to multiply that by 5, so we need to multiply our top by 5. To get the 20 to change, oh, I didn't even have to change the bottom. Nice. So that means I don't even have to change the top. That's going to get us our 8/20. And the second reason why I wanted to talk about B was, let's make sure we always take a quick peek at the end and make sure that we have simplified. Remember, that was the instruction. And I want you to notice that blue fraction means I haven't simplified. I can tell that I haven't simplified because that fraction can reduce the lowest terms. I earlier mentioned, remember, simplify means the least number of operations with the simplest numbers. And so we take a look, 8 and 20, that is a fraction that will reduce. And hopefully we divided top and bottom both by 4, and we got 2/5 as our final answer. So I would love it if we came in with the green solution. Okay, hopefully that one's good. As I said, I would assume you can get there. We just had two little reminders or look-fors to address. I want you to focus in on question C now. So I want you to copy down question C. And for some of us, question C may have felt a little more difficult. It should be easier because anytime we get to work with whole numbers, it should be easier. But for some of us, we actually view C a little uglier. I'm going to pick on you a little bit, and I'm going to pick on your past a little bit. I think that if you view question C to be a little more difficult than B, because it wasn't both fractions, then you are a real algorithm fraction user. That is, you learned a process, you memorize that process, you follow that process, you've gotten very good at that process, but we've lost sight of what's in front of us. So I want to challenge you a little bit on C. So if we were live and in person, and you guys were working on C, then I would float around by your desk, and I would take a look at the strategy you tried in C. And if I saw you put an over 1 underneath that 2, a fraction line divide by 1, to turn question C into one like B, then I want to throw a marker at you. Now, I seriously wouldn't throw a marker at you, but when you take a look at C, I'm going to argue to you that we're losing sight of C should be easier. But your strategy to deal with something like C is to make it 2 fractions as opposed to 1. Because now you have an algorithm, you have a process. And now you would go through that ridiculous, well, I multiply that by 4, multiply that by 4, and you start to go through. And now I need you to see that, look at all the stuff you write on your page that you don't really need. Okay, so first off, we don't need the green. We know if we wanted to get a common denominator of 4, just multiply it by 4. But also, if you knew enough to write over 1, then why do you write it? So at the very least, if we wanted to look at that problem and say, okay, my common denominator is going to be fourths. I'm going to change 2 into quarters. Well, the way I change 2 into quarters is to multiply it by 4. You can see your 8 divided by 4 in your expression. There's your 2. But now I have my other fraction, so I need to add on my 1 more quarter. There's my 9 quarters. So if you want to go through and deal with a common denominator, I would recommend the orange. There's no divide by 1 that even comes into my mind. I want to challenge you to move away from that. The second option, though, on this problem might be, if we're going to add those 2 values together, then what 2 plus a quarter becomes is 2 and 1 quarter. That when I write a mixed number, I'm actually writing a different form of that addition. Now, some people are going to stop and go like, oh, so 2 and 1 quarter, that's my final answer. And I need you to go, no, it's not. Because 2 and 1 quarter is not fully simplified. I want you to take a look at the difference between the orange and the green. And maybe you can see that that green mixed number really has an addition operation and a division operation. That means there are 2 operations in that problem. But if I look back at the orange only has 1. So the orange is more simplified. But I just want you to notice it's pretty easy to change the green. That means change that mixed number back to an improper. So 4 times 2 plus 1 is 9. Keep in mind, you have that as an option always when you have a whole number plus a fraction. Okay, where I get a little concerned is for the number of people who really like the green. That is, you look at question C, you love that green solution. That's good. But then we start to try to do it when we see question D. That is, you look at D and go, hey, I got an add or subtract again. Let's go mix number. And I'm going to tell you to hold off on that. Because clearly, 2 and a quarter is not my mixed number. So my recommendation to you would then be, well, if I'm subtracting my values, why not just go back to my orange? Change 2 into quarters, so it's 8. Now take off the 1 quarter. That's the subtraction. That gets us to 7 quarters pretty quickly, and we should be good. So maybe there was a little bit of a difference in theory of the way you guys would have tackled that. I know coming in that a real common approach is the over 1. And I really want you to work towards moving away from that. That is a really good strategy when you are younger and you are new to this. But let's be better at it now. Okay, that's how we grow with it. Okay, let's jump into our next section. Okay, I want you to go through E, F, and G as fast as you can go. What I'd like you to do, though, is let's check in on each one. So right now, I want you to tackle E, get down to a final solution, unpause the video, see if we match up. Then we'll do the same thing on F, then we'll do the same thing on G. This now becomes an opportunity for you to test your understanding. So let's go as fast as we can go, put a little pressure on ourselves for our calculations. That's how we're going to get in good mental math shape. And we'll see if we match up in the end. Okay, so everyone is tackling E right now. Pause the video, go. Okay, we're back. So we take a look at this one, and we have two different size bits. That means I need the same size bits. If I have 2 and 7, I can turn those into 14ths. But to get my first fraction changed, I had to multiply the bottom by 7, so I have to multiply my top by 7. 7 times 3 gives me my 21. To change my second fraction's bottom, I had to multiply by 2, so I'm going to have to multiply that top by 2. Okay, only thing left to do now is actually subtract my bits. So I take my 21 and I subtract my 8. There's my 13/14, and we should be pretty good to know that that is fully reduced. If I look at 13, 13 is a prime number. And since 13 doesn't go into 14 evenly, we're fully reduced. Or you took a look at 14 and you said, hey, 14 is made up of 7 and 2, and clearly 7 and 2 do not go into 13. So 13/14, perfectly good. I would love to see the orange on your page. Okay, copy down the expression given in F, go through, fully simplify, and again, we'll see if we match up in the end. Okay, pause it now. Okay, we're back. So I would hope that everybody has on their page this orange solution. 18 divided by 2 is 9, 15 divided by 3 is 5, 9 minus 5, 4. Hopefully I see the exact orange on your page. And I would bet that if we were live and I was walking around in person, I might have like 3 of you who have that. And I just want to draw to your attention that you fell into the classic math trap where we deal with every problem like the last way we saw. Stop for a second. Take a look at the numbers in that expression, because your first instinct should always be, can I calculate? Can I calculate? Always. That what we want to make sure we don't fall into the trap of is starting to look at fractions as fractions. Remember, fractions are just whole numbers with division. So the first action we should always look is, can we do the operation? Can we simplify? Look back at question E. That very quickly I go, okay, 3 doesn't divide by 2 well. So rather than changing that into a 1.5, and now, 4 divided by 7, that's going to be hideous. Like that's a 0 point something really ugly. Since those gave us bits, decimals, we kind of skip over that step as we go. We look at it and we say, okay, no, I'm going to work with my whole numbers. I'll just get common denominators. But you take a look at F. I can do my divisions. That's what I should get. Anytime you can do the operation, do it. Okay, since most of us wouldn't have that, I'm just going to put up a solution for what you would have had. So I'm hoping that we had common denominators of sixths. You would have multiplied the 2 by 3 to get to 6. We got to multiply our top by 3. Some of you guys would have had to slow down to calculate 18 times 3. Well, that's going to be my 10 times 3 is 30, and my 8 times 3 is 24, so there's a 54. Now you had to multiply your 3 by 2 to get to 6, so multiply your top by 2. Now we had to do a little calculating, and then we noticed in the end, 24 divided by 4, and there we go. So let's learn something from F. If you have the green solution, that's okay. I would definitely be writing boo on your page for that one. But let's make sure that we add another instinct. Okay, you guys tackled G. I think G is going to be a good indicator for us. Okay, get a full solution to G. Pause it now. Okay, we're back. So we take a look at G, and now I've got everybody looking and going, can I divide? Can I divide? Nope. So I get my common denominator. Common denominator in this case, I got to multiply them together. There's my 35ths. I multiplied my first by 5, so I got to multiply the top by 5. I multiplied my second by 7, so I have to multiply my top by 7. And now I can go ahead and do the subtraction. Negative 25 subtract 14 more gets me to negative 39. And pretty quickly we should see that is in lowest terms. So I'm hoping that through those three problems, we're furthering our instincts. We're adding to them. Things that we can try, strategies we can use. Okay, let's jump into the last section. Okay, I would like you to take a look at H and I. And I would argue I is going to be the ugliest that you will see in your practice for today. So let's start off on H then. I think you have enough in your back pocket to work your way through H. So I want you to go ahead, and once you get down the expression in H, I want you to fully simplify. Let's go, start to finish. Pause it now. Okay, we're back. Now, there's a couple different strategies to be able to play with this. And here's where I might kind of go back on some of the stuff that I said before. That because I'm adding two fractions together, there's a lot of people that could give me a pretty good reasoning for why they would deal with their whole numbers, 1 plus 2 is 3, and then deal with the 3/4 plus 1/6. So you're going to now take 3/4 and add on 1/6 as the fraction part of that mixed number. You now get a common denominator, you put your stuff together, and you're good. I'd be a little weary of that. The reason for it is because there's just a few little snags that can happen when certain values become a certain size. Like, that is a very good approach to deal with. If those two fractions that I have on the inside of those brackets happen to still give me a proper fraction. But if when I find the sum inside those brackets, I get an improper fraction, then I've just seen way too many mistakes with you now converting that into an overall improper fraction. And I would argue to you, don't even bother inviting that mistake. So I think it's an okay strategy for you. You just have to be really disciplined. My argument to you would be, if you were fine to tackle each one of the last three problems, then why not make H look like the previous three? That to spend one line and say, okay, I'm going to make 1 3/4 a mixed number. Sorry, an improper fraction. I'm going to switch it from being a mixed number. 4 times 1, add on 3 is 7, 7/4. Do the same thing with the second fraction. 2 and 1, 6, so 6 times 2 is 12, add on 1 is 13, 13/6. Well, now I just made that look like question G, or F, or E. Now we should be good to finish it off. So if you ran into a snag, I'm going to ask you to pause it and try to finish off that on your own. Otherwise, you're coming along with me for a final solution. Okay, I think we have the blinders on if our next action was this. I'm hoping that we do not have a common denominator of 24 because we broke those down into too small a bits. We made our bottom too big. It didn't have to go that far. We can change 4ths and 6ths into 12ths pretty easily. So how can I change it into 12ths? Well, I multiply my 4 by 3, so I multiply my top by 3. In the second fraction, I multiply my 6 by 2, so I multiply my top by 2. Now I can go ahead and add them, and there is a 47/12. Okay, quick peek. Is that fully reduced? And I look at my smallest number maybe, and I say 12. Well, 12 is made up entirely of 3s and 2s. I hope you can see with that factor tree why it's 3s and 2s. Because my 4 is made up of only 2s. So the only numbers that I need to focus in on are 3s and 2s. So I take a quick peek into 47. Clearly, 2 doesn't go in. because it's not an even number, so that's nothing to worry about. And then if I use my sum of my digits trick, 4 plus 7 gives me 11, and 3 does not go into 11 evenly, so I know it doesn't go into 47 evenly. That fraction is fully reduced, and we are good. So even though question H looked a little more difficult maybe than the previous, notice if I just spend my time to put in one additional line, convert my mixed numbers into improper fractions, now I can treat all my fraction problems the same. Okay, I want to leave you with question I now. So let's go start to finish. You can see that it looks uglier than the previous problems, but I think question I is going to be a great gauge for us at the high end. Like seriously, I don't know if I'm going to throw anything worse at you in your practice for today than I. So if you feel pretty confident to work your way through I and we match up in the end, then I think you've already got some great practice done, and probably your practice that you're going to put in is just about drilling in the most difficult problems. So let's use I as our gauge. Okay, pause it now, come back when you're done, and we'll see if we match up. Go ahead and pause it. Okay, we're back. So a couple things that I might say in terms of strategy. I'm going to do this solution in blue. I think I would take this as a first action. If we like the previous problem of change all your mixed numbers into improper fractions, then I'm going to change my first into an improper fraction. But at the same time, I recognize that I've been given some double signs. So why don't I change those into single signs at the same time? So in that first case, I was adding a negative. Well, then that means that I really subtract my value and now change my mixed number into an improper fraction. So my 3 times 1, add on 2, there's a 5. 5 what? 5/3. Now in the last term, my double sign is subtracting a negative. Well, I know that that means I really add the value. And the nice part is that was already a proper fraction. I don't have to change it. So we get into that instance. I don't like my sloppy 5 up here. I'm just going to clean that up a little. And there we go. So if we have that expression, then I may have caught up with you. Maybe we make some adjustments and we finish it off again on our own. Okay, next part for me is I don't want to go ahead and get a common denominator between 8 and 3, figure that out, then get a common denominator with my 6. If I'm just going to subtract the first 2 fractions and then add the last fraction, why don't I just change them all to the same size bits? So I'm going to get a common denominator for all of them. Now, that's a pretty sloppy fraction line, so let me clean that up a little. Okay, I go through my 8 times table, my 3 times table, my 6 times table. Or I look at all my denominators. Well, 8 is like a 4 times 2, and 3 is like a 3 times 1, it's prime, and 6 is like a 3 times 2. So if I just need to put in all those factors, I can get there. You choose however you want to be able to get your common denominator, but I would hope pretty quickly we could come up with a common denominator of 24. I can get my 24 by multiplying my 8 by 3, so I multiply my top by 3. I can get there by multiplying my 3 by 8, so multiply my top by 8. And I can get there by multiplying my 6 by 4, so multiply my top by 4. Put them all together, and hopefully we end up getting a 55/24. And in this case, if I factor the top, 55 is only 5 and 11, and 5 and 11 do not go into 24. I should say 5 or 11. And therefore, I know that that blue is fully reduced. Nice. So if you were able to work your way through and get down to that blue solution with a pretty similar step, I think we're doing great. Your job now is to get some practice to the point where this stuff just becomes automatic. We can drill it in so it becomes reflex. Okay, best of luck with your practice.